All right, we're going to be talking about Chapter 9 the next couple weeks. Chapter 9 is a geometry unit. The first couple of sections we're going to be talking about just some terminology like points, lines, planes, angles, circles, things like that. Getting to Section 3 this week, we're going to be talking about congruence of triangles, similarity of triangles, and Pythagorean theorem. We're going to get into some area and circumference, volume and surface area, and some of the transformational geometry. So today we're going to be talking about points, lines, planes, and angles. So it's a lot of definitions mostly. So with this section, what we're talking about is the geometry of Euclidean geometry, or what is Euclidean geometry. We're going to be talking about points, lines, and planes, and we're going to be talking about angles. So Euclidean geometry has basically three main definitions that everything is built upon. The first one is the definition of a point, and a point is something that has no magnitude and no size. So magnitude would be like weight, if you think about it that way. A line is something that has no thickness and no width, and it extends infinitely in two directions. So again, these are our primary definitions that we're going to work with. A plane is a flat surface that extends infinitely in all directions. So a lot of times what we'll do is we'll think of a plane as a piece of paper, even though that doesn't extend infinitely. We think of a line as a line on the piece of paper, and a point as a point on the piece of paper. So we usually use capital letters to represent a point. It's extremely important that you do use the proper cases because when you're looking at definitions, you need to know whether you're looking at a point or something else. So a capital letter is always used to represent a point. A line is formed by 2 points. So a line always is named using 2 capital letters. You also will use some symbolism above this also. A plane is represented by 3 capital letters. So if we look at this example here, we have a number of points in the problem. We have point A, we have point B, point D, and we have point E. We have a line, and our line is DE, and we use a symbol above the line to show that it's a line. We could actually say that we could create a line from A to D, because any 2 points that we have in the picture form a line. So if I wanted to, I could come over here and draw a line from A to D. We have a plane, and the plane that we have here is ADE. Okay. We could also name this line DE equal to lowercase l, and we could name this plane that we created here with the Greek letter alpha. So we also have a couple more definitions. We have something called a half line, a ray, and a line segment. Now a ray is formed by a point and half of the line. So for example, if I had a picture that looks like this, okay, that's what we call a ray, and that would be called ray DE. And we denote it with the symbol above it showing that it starts at D and goes towards E. It would be incorrect to reverse the letters and say ED. Okay, you cannot reverse the letters. The first letter has to represent the starting point, and the second letter has to represent the direction that it's moving towards. We could say that this same picture has a line segment. The line segment is DE, and we represent that with a bar over top, usually with 2 points on each end. Sometimes you'll just see the bar. So a line segment is the two endpoints and all the points in between. A half line is from the starting point all the way out, but it does not include the starting point. So usually with the half line, your picture will look like this, with the open circle at D, and our symbolism again is DE, but we have the open circle here instead of the closed circle. All right, so here's like a summary of everything. So with a line, we can name the line using the letters in any order. So I could say AB or BA. And the symbolism that I gave you was the line segment above it. The half line is called AB again. And you have the open circle at A and the closed circle at B. The half line BA just means it's moving in the opposite direction. Ray AB, ray BA, again moving in the opposite direction. And with segments, you can name it as AB or BA, just like with a line. So let's go back and show you that again. With a segment, you can name it either way, and you're naming the exact same piece of information. So then we have something called parallel lines. And parallel lines are lines that are in the same plane, but they never meet or they never touch. And then we have two distinct intersecting lines that meet at a point. So intersecting lines do touch at one point, and parallel lines do not touch. Now, skew lines is an unusual term that we don't see very often. But lines that are skew are lines that do not lie in the same plane, and they never meet. So a good way of looking at skew lines, you could think of skew lines as the telephone lines and the street. And the telephone lines, here are our telephone lines. And here's the street. Telephone lines do not ever touch the street unless there's some sort of problem and they fall down. But telephone lines do not touch the street. And they are not in the same plane because they are above the level of the street. So they are considered to be skew. So they're not considered to be parallel in most cases. All right, so once again, parallel planes is just talking about planes now instead of lines. Parallel planes are two planes that never meet, and two distinct intersecting planes that meet form a straight line. So again, imagine if you took two sheets of paper and slid them together. So you have this sheet of paper and this sheet of paper. If you slide the two sheets of paper together, maybe cut a slit in one and slide them together, where they touch, they form a line. Where those two planes touch, they form a line. And you'll see right here is the line that they are forming. Okay, so this is important to remember. Intersecting planes form a straight line. All right, and then we have an angle, and an angle is the intersection of two rays that have a common endpoint. So again, it's two rays, and they have a common endpoint, and that common endpoint is called the vertex. Okay, so there are a number of ways that we can name an angle. We can name the angle just simply using the vertex. So I can call this angle B, and a lot of times I might just write the symbol angle B. Or I can name this angle by naming the letters on the sides and going either clockwise or counterclockwise. So I could say angle A, B, C, or angle C, B, A. Now notice in both of these cases, the second letter, B, is our vertex. And in order to properly name this angle, I would have to have the vertex as the second letter. If I tried to name this angle, angle CAB, that is incorrect. Okay, the second letter is A, and that is not our vertex. So I want you to name these two angles. Okay, so the first angle, we could either name it angle R, or we could name it angle XRQ, or we could name it angle QRX. The second angle, I could name it angle N, or angle MNP, or angle PNM. Okay, so we have different ways of measuring angles. So we measure angles by looking at how much they've rotated in the amount of rotation that we have there. So the first angle that you see here has about a 45-degree angle. So when we look at this one's a fairly easy one. When you look at that and you look at a 90-degree angle, think about the edge of a piece of paper or the edge of the building, a 90-degree angle. So a 45-degree angle is just about half, or it is half of this 90-degree angle. Then we have a 10-degree angle, which means how much is it rotating from that straight line. We have a 150-degree angle, and then this one, you wouldn't know unless I told you, is a 360-degree angle. Okay, so then we have names to classify the angles. If an angle measures less than 90 degrees, but at least 0 degrees or at least 1 degree, then it's considered to be an acute angle. So if we go back for a second and look at these examples, the first example here would be acute because it is less than 90 degrees. This example here would also be acute. Our second option is that the angle is a right angle. And a right angle is only right if it measures 90 degrees. So again, going back to that example that we just had, this second picture here would be a right angle. And I'm going to go ahead and label these while we're here. This angle would be obtuse. Oops, I spelled it wrong. Obtuse. And an obtuse angle is greater than 90 degrees, but less than 180 degrees, and that's an obtuse angle. Now a straight angle, there's not a picture of a straight angle on that other problem, but a straight angle would look something like this, where we have a letter here, maybe even a letter here, so we would say X, Y, Z, and this angle would be called angle Y, or angle XYZ, or angle ZYX, and these are all considered a straight angle. And whenever I'm trying to show people that, I try to show you that it makes a half of a circle, and a half of a circle is 180 degrees. So a tool that we use to measure angles is something called a protractor. And the way that a protractor works is there's usually a hole or a dot here in the center, and you'll line that dot up with the angle. And for example, we're looking at this blue angle here, and we're trying to measure it at this angle. Well, we know that this angle is obtuse. So obtuse means it has to be between 90 and 180. So when we're looking at these measures over here, you have to look at your protractor, because many times you'll have two different numbers there. You'll have a small number on top and a larger number on the bottom, because you can hold your protractor either way. So this is going to be read between 130 and 140, so it's approximately 135 degrees. When two lines intersect to form right angles, those two lines are called perpendicular. Perpendicular. And the symbol for perpendicular is an upside down T. So if I wanted to look at this and say, here's line L and here's line M, I could say L is perpendicular to M. I did forget to give you the symbol for parallel, so let's go back a few slides real quick. Oops, there we go. Okay, so here we have parallel. The symbol for parallel is two lines up and down. So let's look at this one. If this is called L and this is called M, I would say L is parallel to M. So the symbol for parallel is two lines straight up and down. Okay. All right, so we're going to talk about perpendicular a little bit more, not much. Oops. Okay. So another term that we have here are vertical angles. And angles are vertical when they are formed, they're angles that are formed by two intersecting lines. So I have line, in this case I have line DC, and I have line AE, and they're intersecting at point B. So AE and DC form vertical angles. And the vertical angles in this case are this angle on top, and the angle directly across from it, this angle on the bottom. Those angles are vertical angles. And I have two pairs of vertical angles here. This pair over here is also, and this pair over here. Now notice that the black angles that I mark here are both obtuse. And the red angles that I marked are both acute. So when you're looking at these angles and you're trying to determine what's their relationship, since both of the angles that are in red are acute and both of the angles that are in black are obtuse, they do have equal measures. So I know that those angles are equal to each other. So we're going to use that quite a bit to solve equations and figure out missing angles. So let's look at this one. I've given you some of the answer. So when we look at these two angles, what I want you to look at is a couple things. This angle right here is 5x minus 10, and this angle right here is 3x plus 10. So we're trying to figure out what x equals so that we can figure out what the measure of each of the angles is. Well, we'll notice that both of these are acute. Both of the red marks are acute. So that means that those two angles are vertical and they are congruent. They are equal. So these two angles are equal to each other. So we're going to set them equal, and now we're going to solve for x. So to solve for x, our goal is to get x by itself on one side. So I'm going to move this 10 from this side to this side. And remember, when we want to solve an equation, we have to do the opposite operation. So now I have this cancels out, and I'm left with 3x on the left. The 5x is still on the right, and negative 10 and negative 10, or negative 10 minus 10, is negative 20. Now I need to get this 5 over to the left because I want to get the x's on one side. So we're going to again do the opposite operation and move that 5x to the left, and I get negative 2x equals negative 20. And I've got one more step. I'm going to divide both sides by negative 2 to get rid of the 2 that's with the x. And so x equals 10. Now, a lot of times what will happen is, you'll notice that I did this one slightly different. Depending on which order you move things around in, you're still going to get the same answer, but I have a tendency to end up with my negatives and things like that. So if you're confused about this, just look at the example that I showed you. Once I've got the value for x, then I have to take that value and substitute it back up here. So in the example at the bottom, I substituted it into the 3, but it doesn't matter which one I substitute it in for. So I get 50 minus 10, which is 40. So again, they're just sort of showing that these two angles are equal, because down here at the bottom we did it, and we ended up with, I'm going to erase this a little bit. we ended up with x equals 40 also when we substituted it into the other side. All right, so two other definitions, complementary angles and supplementary angles. So complementary angles are two angles that can be added together to make a sum of 90 degrees. They are not necessarily connected to each other. I could just give you two random angles and say this one's 40 and this one's 50, and because they are both equal to 90 degrees when we add them, they're complementary. Supplementary, on the other hand, are two angles that add together to equal 180 degrees. So one way, this is something that students tend to forget, complementary is the letter C, and supplementary is the letter S. So one way that the students do tend to remember this is if I draw one line right here, I have a 9. But if I draw one line right here, I have an 8. So this looks like 180 because it's got the number 8 in it, and this looks like 90 because it's got the 9 in it. So then we have this problem. Find the measure of each of the angles marked below. So what we have to do is look at the relationship between these two angles. So this angle is an obtuse angle, and this angle is an acute angle. If I put those two angles together and I move from this side of the angle to this side of the angle, I have a straight line. So this is a straight angle. When I put the two pieces together. And straight angles, if you look back at that chart, are always 180 degrees. So these two angles are supplementary. Again, supplementary means two angles that add together to equal 180 degrees. So that's what we're going to do. We're going to take the 2x plus 45, and we're going to add the x minus 15, and we're going to set that equal to 180 degrees. We're going to continue to solve this, so we're going to combine the 2x and the x together and get 3x. We're going to combine 45 and minus 15, and you're going to get 30. We're going to keep solving this, and we're going to subtract 30 from both sides. So this is where I got this line, 3x equals 150. And then we're going to divide both sides by 3. So x equals 50. And now we want to know the measure of each of the angles up above. So we have to take that 50 and plug it in to each equation that we have up above. So 2 times 50 is 100, plus 45 is 145. If I plug it into the other equation, 50 minus 15 is 35. So this angle right here that's acute is 35 degrees, and this angle over here that's obtuse is 145 degrees. And notice those two numbers add together to equal 180 degrees. All right, so here's another one. Now this looks a little bit like a vertical angle problem, and initially you might think that it is vertical. But what you have to do is look at these again, and this is what I'm going to keep stressing. When you look at this angle right here, it's an obtuse angle. And when you look at this angle right here, it's an acute angle. So these two angles are not the same measure because one's bigger than 90 and one's less than 90. So when you look at those two again, you'll notice that when you put those two angles together, they are a straight line, and a straight angle is 180 degrees. So these are supplementary. So we're going to set up our problem, 3x plus 15 plus 5x plus 15, I'm sorry, 3x plus 5. Sorry, plus 5x plus 15 equals 180. And then we're going to keep solving this, so we're going to get 8x plus 20 equals 180. That's what I have right here. We're going to subtract 20 from both sides because we have to solve for x, and we get 8x equals 160. Divide by 8, so x is equal to 20. And then again, we're going to take that information and substitute it into the problem. So we have 3 times 20 plus 5 is 60 plus 5, which is 65. And 5 times 20 plus 15 is 100, plus 15 is 115. And again, you'll notice that if you add these two numbers together, 65 plus 115 is 180 degrees. So you've worked it out correctly. All right, the last topic that we're going to talk about here are dealing with parallel lines. And these parallel lines are being crossed by what we call a transversal. And a transversal is just a line that traverses or goes through the parallel lines. So this is my transversal right here, and these are my parallel lines. So we have L and M. So L is parallel to M, and the transversal, a lot of times we'll call it T. The transversal is T in this case. So you'll notice that when you draw this picture, if you can imagine that you've got like a rectangle right here. And so when you look at this shape, this part of the picture is the interior of the picture. It's the inside of the picture. And the part up here and the part down here is what we call the exterior. It's outside. So there's the exterior, and this is the interior. So we have 4 different angle measures that we're going to look at with this type of problem. And what we're going to look at, they have different properties associated with them. So the first one that we have here are alternate interior angles. So remember what I told you just now about the interior and the exterior. So this angle 4, they're just calling this angle 4, and this angle 5 are both on the inside of the shape. They are on alternating sides. Alternating means opposite sides. They're on opposite sides on the interior. This angle, number 4, is obtuse. And this angle down here is obtuse. Number 5 is obtuse. So since both of the angles are obtuse and they're on alternating sides and they're on the interior, they are equal to each other. Now what I'd really, really like to stress to you is to pay attention to whether the angles are the same or different. Are they both acute? Are they both obtuse? That means they're the same. Or are they different? Is one acute and one's obtuse? So depending on what you have there, you will have whether the angles will be congruent to each other, or another option would be supplementary. So another pair of alternate interior angles are these angles that I'm marking in red. Those are also alternate interior angles. Those are the only 2 pairs of alternate interior angles. So these, the next example you see, these are alternate exterior angles. Remember the inside and the outside. They're on the exterior or the outside of the problem. Notice again, this is an obtuse angle. This is an obtuse angle. Both of the angles are obtuse. They are equal in measure. Another pair of alternate exterior angles is this one and this one. And again, both of those are acute, so they will have equal measures. Okay, so here we have 2 more interior angles on the same side of the transversal. Depending on what your book is that you're looking at, I'm going to assume that that's what they're saying. These also might be called, there are a couple different names. Another name for these might be same side interior, which is an easy name to remember, the same side on the interior. So again, we're looking at the inside of the angles. We're looking at angle 4 and angle 6 because they're both on the inside. You'll notice that this one is obtuse and this one is acute. So since one is obtuse and one is acute, they are not the same. They are different. And if they are different, they're going to add to 180 degrees. They're going to be supplementary. Another pair of alternate interior angles is this angle over here and this angle over here. The last angle that we have here is what we call corresponding angles. Now notice you do not see the word interior or exterior, and that's a very good clue for you, because you'll notice that 6 is on the interior, but 2 is on the exterior. So in a corresponding angle problem, 1 will be on the interior and 1 will be on the exterior. Notice again that they're both acute, so that means that they have the same measure. So in this problem, we have quite a few corresponding angles. This angle right here corresponds to this angle right here. So my red angles are corresponding. My green angles right here, this green angle right here corresponds with this green angle right here. And we actually have one more, and we'll call it, I think it should be black. This angle right here corresponds with this angle right here. All right, so let's say we had this example and we wanted to find the measure of, again, the measure of x. So we'll look at these two angles. We'll notice that they're both obtuse. They're on alternating sides on the interior, so they're alternate interior angles. So they have the same measure, so we're going to set up our equation as x plus 70 equals 3x minus 80. And then we're going to continue to solve this problem. And again, when I solve this, I'm going to get a little bit different format than I have down below. But we're going to end up with x equals 3x minus 150. Subtract the 3x from both sides. So we get negative 2x equals negative 150. Divide by the negative 2, so x is 75. So I got the same answer, but I did drop some negatives and things like that. Again, we're going to substitute in to find the missing angle. So you're going to have 75, sorry, we're at 70. 75 plus 70 is 145. So since they're alternate interiors, I know that both of those are the same angle measures, so they're both 145 degrees. In our last example here, we want to find the angle measures again. Notice that this angle is obtuse, this angle is acute, so they have different measures. They're on the same side of the interior, so they are called same side interior angles. And for same side interior angles, we know that they should equal 180 degrees. So we end up with 5x minus 55 equals 180. I'm going to add 55 to both sides. So I end up with 5x equals 235. Divide both sides by 5. And so we end up with x equals 47. Again, taking that number and substituting it in up here, we end up with 48 for this angle and 132 for this angle. And again, since they add up to 180, we know that we did it right. I hope this is helping. Please keep in touch with me, keep up with your work, and let me know if you need any help on your work. And have a great week.